So for this problem, we want to differentiate ln(y) over x plus 1 with respect to x. So in order to do this, we need to recognise, first of all, we have the two variables again, x and y, so we're going to need to use implicit differentiation, but it looks like a fraction, and if it looks like a fraction, there's a rule that we can use, which is our quotient rule, okay? And just like with the product rule, we need to get our four parts for this. So let's work out what these are. We have our u, which is ln(y). We have our u dash, which is the differential of ln(y) with respect to x. So first of all, we differentiate it with respect to y, which is 1 over y, and then we multiply that by dy by dx. We have our v, which is our denominator, which is x plus 1, and we have our v dash, which is the differential of x plus 1 with respect to x, which just gets us 1. And if we have those four parts, then we can substitute it into our quotient rule to say, therefore we have our v, which is x plus 1, times our u dash, which is 1 over y, times dy by dx, minus our u, which is ln(y), times our v dash, which is 1, all over our v squared, which is x plus 1, all squared. So just tying this up a little bit then, therefore we can say that we have x plus 1 over y times dy by dx minus ln(y) all over x plus 1 all squared. And if you want to, we can separate that into two parts, because really from our first part of the expression we can simplify one of the x plus 1's. So we can say that we have 1 over y x plus 1 times dy by dx minus ln(y) over x plus 1 all squared. Either of those forms would be correct, but in this form we've just simplified one of these x plus 1 to get rid of one of them, okay? And that's what we would get if we want to differentiate ln(y) over x plus 1 with respect to x.